describe the PDF of this curve is a bell-shaped curve. Usually, if you observe the bells in the temples or at any other places, it has a similar shape. So x-axis is the asymptote to the curve. That how do you derive the asymptote, that you know already. So one can easily derive the uh, asymptote of this curve. It's symmetrical about x equal to mu. So that is also easy to verify. Mean, median, mode, they are all equal. So mean is the value, is the central value, which we represent by expected value of x. So usual procedure is calculating the expectation of a random variable x into fx dx. So if you simplify this integral, you will get the mu. But I will, instead of simplifying this, I will show you the general form of the moment generating function so that you can derive all the moments. Median is the value which divides the distribution into two equal parts, that half of the area, because total area is to be 1. So we are looking for a point below which area is half, above which area is half. So usually we know the CDF of a random variable. So if you solve probability, basically in order to get the median, that median is a point on the x-axis. So if we denote the median as MD, then we have to show that we have to solve the value of median such that probability x less than median is half, or x greater or equal to median is half. So one of the integral you can easily solve, minus infinity to MD fx dx is equal to half. Solving this integral, you will get the value of MD. So instead of solving this way, I will show you that there is a easier way of getting the value of median. So any percentile or quantiles you can derive. Say there is a general rule that you are looking for any value of, in place of MD, any x star you can put it, x less than x star, and this side you can put p value. P lies between 0 and 0 to 1. Then you can get the various type of quantiles, which are if you multiply by 100, then it is known as the percentile. So first quantile is 1 by 4th, that if you put 1 by 4, you solve that. If you put 3 by 4, then it is 75% below that. Area will be between the less, area will be below that point. So these are the things which you can easily study in the books. If time permits, I will explain a little bit more sometime. But the idea is that from the CDF of a random variable, you can easily derive in any value of x star, x less than x star is equal to p. So solution of, for a given p, the x star will give you the value below which the area will be p. So this is how the median we have got it. And as I told you that there is a easier way to calculate this using the tables of the normal distribution. Mode is the value at which the fx achieves the maximum value. So mode, as you know, is the more frequently occurred value. So in this case, we know the density function. The usual procedure is there that you take the derivative, equate to 0, and second derivative uh, you show that it is less than 0, so you will get mu. So again, the derivation I am skipping because it's all standard. So ultimately, if you look at the picture also, picture means the graph of the normal distribution, all this mean, median, mode is equal to mu. Then it has a very important property, area property. Area property means between mu minus sigma to mu plus sigma, 68% of the area, mu minus 2 sigma to mu plus 2 sigma, 95% of the area, mu minus 3 sigma to mu plus 3 sigma is 99% of the area. So these points are located on the graph. As you can see, mu minus 3 sigma, mu plus 3 sigma covers your 99% of the area. Okay, so beyond this, beyond mu plus sigma or below mu minus 3 sigma, the area is almost very small and is a negligible quantity. So we will show you that tables, etc. So how these value we have got it, this value either you calculate the solve the integral, or there is a easier way using the table that these value we can find out. So I will show you that how these values have come. So the main question is that how to evaluate the probability. So as you know, in case of the continuous random variable, if I want to find the probability x lies between a to b, and if I know the form of the density function, say uh, in this case there are two parameters, mu is 75, sigma is 4. So you put mu 75, sigma 4, and a you choose say minus 1.5 to 1.75, and solve this integral. So because this given mu and sigma, this integral will be known, lower and upper limit will be known, but evaluation is not easy. So as numerical procedures are applied to get the value. So what is done in order to simplify the calculation, and as I told you, normal distribution is a very important distribution, uh, and whole of the statistics is dependent on this, and it is frequently used. And as you will see at a later stage, there is a very important theorem, central limit theorem, where uh, distribution of the sum of the random variable can be approximated by normal distribution. So keeping the importance of these distributions, tables have been generated so that people can use frequently instead of calculating the integral. So how it is done? So it is done that if I have to calculate the area between A to B, the original random variable is x, which is normal. So what we do, we transform into a new random variable. How it is done? It by subtracting mean, dividing by standard deviation. So this particular transformation, that x minus mu by sigma, is represented by capital Z, and it is known as standard normal variate. Now, what is the property of the standard normal variate? That its density function will be normal. Of course, I have not taught so far that if you know the distribution of x, you can find the distribution of z, but it is easier. There is a topic on function of the random variable. We shall discuss at a later stage. But here, it the distribution of z will be normal, and mean, as you can see, is easily, you can easily calculate, mean will be 0 and variance will be 1. So whatever be the original random variable x you have with certain mean and certain variance, if you subtract mean, divide by the standard deviation, then you will get the z, and distribution of z is normal 0, 1. So usually that density function we obtain is 1 by root 2 pi e to the power minus half z square. So you can easily see this particular density function does not involve any mu and sigma. Okay, so now it is still a form of the normal distribution, but mean is 0 and variance is 1. So if you plot this, then you get a similar curve with central value 0, which is mean, median, and mode, all will be 0. And then mu plus sigma, mu minus sigma points will be minus 1 to 1, minus 2 to 2, minus 3 to 3, etc. So now the there are two this particular transformation is so important that instead of writing fz, small phi z is written to represent the PDF of the standard normal variant, and capital phi z is used to represent the CDF of the normal. So if I have to calculate the area, what I will do is I will convert the original probability into the form of standard normal. So how it is done? We subtract mu and divide by the standard deviation in all the values from a, x, and b. So a minus mu by sigma, x minus mu by sigma, b minus mu by sigma. This becomes a new variable z, and these are the new points. From original point, we have got a new point which we represent by z1 and z2. So using the usual property of the CDF, we can write as phi z2 minus phi z1, as I indicated earlier, that capital, here I have mentioned that capital phi z is used to represent the CDF of the normal distribution, and it represents the area between minus infinity to any point z on this side or this side. So tables have been generated in the form of the CDF. There are two forms of the table. One is from CDF, another is 0 to some positive point. So I will be explaining you the table. So having done that, as in a summary form, the PDF of normal is this, and we have the standard normal phi z. So as you can see, minus infinity to z, that blue color shaded area, this area has been tabulated. Okay, so tables, how the tables will look like. In the last class, I think I have shown that, and I have uploaded also. So there are several tables. One extensive table I have uploaded. Okay, so in between I will be okay. So if you look at this table, because this is very important, and you have to learn this in the examination, the tables are usually provided. So as you can see, the tables are given in the form of the CDF minus infinity to any point z on this side. So minus infinity. So in the first column, z values of the first decimal places and the second decimal places on the first row. Say 3.3 5 if I have to obtain, then 3.3, then 0.05, so 0.004. So if the z moves on this side, then we have the here. So z in the positive side, then minus infinity to z. So it's a cumulative probability. This type of table is known as the cumulative probability tables. So you can find out the area or respective probability from any point in the form of minus infinity to z. Okay, so we can
Sir,
easily bolo.
what is this 0.01 to 0.09? For what
This is the
purpose?
second, as I told you. Now, say suppose you have to find 1.25. Okay, so 1.2 on the first column I will choose here. Okay, and 5 will be on this side. So 1.25, the value will be 0.8944. Did you get it?
Yes, sir. Okay.
Okay, so that's what I told you. This is the after decimal first place, and this is the second decimal place. Okay, so using this table, we can calculate all sorts of the probabilities required in usual application. So let us first see. Uh, I think you have the table, so it will be better if you open your table, because otherwise I have to keep opening and closing all the times. So it will take more time. So main thing is that you have to understand the table. Anyway, if required, I will do it again. So now I'm coming back to the lecture part. So here, as I told you, that if I have to calculate the probability x lies between A and B, simply you subtract mean divide by the standard deviation, convert into the standard normal variate. So you need to find out this one. This probability, say suppose Z1 is coming on this side, Z2 is coming this side. So we know the property of the CDF, that this is equal to phi Z2 minus phi Z1. As I told you, phi, the capital phi symbol is used in most of the books, but still you will find the books where the people will be using FZ and small fz. So before using the table, you should see what is the representation. So this is basically phi of Z2 minus phi of Z1. So phi of Z2 means probability Z less than Z2. Okay. And from z less than z2, you subtract z minus infinity to z1. So it becomes phi of z2 minus phi of z1. So phi represents the CDF. That here, uh, here minus infinity to z small phi x dx. So this area has been tabulated. Now I'll show you by means of example. Say suppose x, this is just artificial example. X is normal, mean 5, variance is 9, and represent. Note that this, when we write that distribution in the normal form with 5 and 9, the first one represents the mean, second one represents the variance. So don't get confused that people generally take sigma equal to 9. So you first write that mu is equal to 5 and sigma square is 9. And then you get sigma equal to 3. Otherwise, what people do, that 9 is there, so you divide by 9. So that is wrong. So standard symbol is normal mu sigma square. So mu is 5, sigma square is 9. So if I need to calculate x greater than 7, so what should I do? I will just convert into the standard normal. So x minus 5 divided by 3, 7 minus 5 by 3. So this becomes z, because this is a standard normal. Z greater than 2 by 3. 2 by 3 z greater than 0.66. So 0.66 means this area, that black shaded area. You need to find out. Now your table is not there in this form. Table is there from minus infinity to any positive point or any negative point here. So we can use the property, that complementary form. So if I subtract from total area is 1. So from 1, if I subtract this area, then I will get the area of this black region. So that's how it is represented. So 1 minus probability z less than 0.66 I have written, and this phi 0.66 is there. Now this you have to find out from the table. So it is coming 7.7454. So now again I will, this is the problem. All the times I have to, you have you got the tables? Otherwise I have to switch over all the times. Anyway, let me show you one. So we needed, so we needed 0.66. So 0.66. So what you do? Here is 0.6. Okay, this one. Then another second decimal you will choose from here, 0.6. So now the corresponding to this row you come. So here, this value 0.7454 will give you the area from minus infinity to 0.66. 0.66 the point which lies on this side. Okay, so this value we have got from the table. So again I am, so this is the value we have got from the table, and you substitute, you will get 0.2546. Now second example, suppose we have, so here in the continuous case, does not matter any interval, whether you include both the sides or exclude the both sides, because it's a continuous. So now when the probability x lies between 2 to 11 is needed, then what we do, same thing, we subtract mean, divide by the standard deviation, and ultimately you need to find the area between -1 to 2. So -1 to 2 means phi up to minus phi up -1. So phi up to, again you have to see the table. I'm not switching again. You can look at your place. So phi of 2, phi of -1, phi of 2, again 2 will be on this side, so 0.97725. It also gives an idea that how much, suppose sometimes you write the wrong value. Say if you are writing 0.34, then it is wrong, because is phi of 2 means area has to be greater than 0.5, because total area has to 2 will lie on this side. So intuitively also it should be clear in your mind that if sometimes you choose the wrong value, you should think that I have chosen the wrong value. So this phi of -1 is this, and this way if you subtract, you will get this area. So in normal distribution, most of the problems ultimately results into finding the probabilities lying between the certain values are greater than or less than. So all these values can be easily obtained using the tables of the normal distribution. So now coming back, that showing you that how did we get the area between mu minus sigma to mu plus sigma 0.68. So same way, x follows normal mu sigma square. We need to find this area mu minus sigma to mu plus sigma. So what I will do, I will convert into the standard normal. So convert into the standard normal means I have to subtract mu and divide by sigma throughout. So here I have mu minus sigma minus mu by sigma, and this automatically becomes z. You need not to write always. So whenever you subtract mu and divide by standard deviation, it becomes the norm. So I have directly written z, and then mu plus sigma minus mu by sigma. So if you simplify this, you get -1 to 1. -1 to 1, these 2 points. So capital phi of 1 minus phi of -1. So you will phi of 1 you will get from the table 0.84134, and phi of -1 you will get from the table, so 0.6826. So in general we call that mu minus sigma to mu plus sigma, the area is 68%. Okay, so it's easier to remember. Hello.
सर इधर p of -1 को ऐड नहीं करेंगे क्या? Like p of -1 less than equal to z less than equal to 1 है. So if we do phi of 1 minus phi of -1, फिर probability of -1 को ऐड नहीं करेंगे क्या? At x equal to -1.
नहीं ऐड कर, आप ये देखो ना एरिया, आप ये शेडेड एरिया चाहिए. ओके, so phi of 1 what it represents? It represents is a cumulative. So minus infinity to 1 होगा, minus infinity to 1 you have got 0.8413. Then -1 is this side, so minus infinity to -1. If you subtract, so from the larger area is that okay?
इंक्लूड हो जाएगा ना अगर मतलब
नहीं
phi of
नहीं,
minus.
अरे इंक्लूड कैसे होगा? आप देखो ना, आप अभी मैं इंक्लूड नहीं होगा ना, आप कैसे करोगे? माइनस से आप यहाँ से लेके यहाँ तक का पूरा एरिया निकाल रहे हो ना, ये माइनस इंफिनिटी टू 1 ये रिप्रेजेंट करेगा, पूरा करेगा कि नहीं करेगा? पूरा ये रेड पोर्शन करेगा कि नहीं? माइनस इंफिनिटी टू 1, यस और नो?
यस सर.
ठीक है, अब इस एरिया में से यू आर सब्ट्रैक्टिंग दिस एरिया माइनस इंफिनिटी टू ये जो -1, क्योंकि टेबल्स आपकी माइनस इंफिनिटी टू सम पॉइंट है ना. सो माइनस इंफिनिटी टू -1, phi of -1 what it represents? minus infinity to -1. तो you need the area between -1 to 1. तो बड़े से छोटा सब्ट्रैक्ट करेंगे ना. Is that clear or not?
यस सर.
ठीक है. वो नॉर्मल डिस्ट्रीब्यूशन में it is always advisable, means we advise the students or even Now I still use that, draw a simple curve and then put the points and look for what area you are needing. So it's easier to see from the table rather than directly you do it. Okay. Similarly, mu minus 2 sigma to mu plus 2 sigma, same transformation आपको करना है. You are subtracting mu, dividing by the standard deviation. So this x becomes z. These are the new points. New points are minus 2 to plus 2. So again, आपको क्या है? Minus infinity to 2. This area has been given, and from the larger area you subtract minus infinity to minus 2. So you get the area between minus 2 to plus 2. So phi of 2 value you can see from the table. Phi of minus 2 you can see from the table. So it becomes 0.95. कुछ और आ जाएगा. So around 95% of the area. So similarly, आप 3 में जाओगे, तो when you convert this into standard normal, it becomes minus 3 to plus 3. Same way. So phi of 3 minus phi of minus 3 means minus infinity. जैसे ये हो गया, आप नहीं बनेगा, इससे नहीं बनता. तो एनीवे, हाँ, तो ये हो गया. तो माइनस 3 ऐसे नहीं बनेगा, इस पर वेरी डिफरेंट. सो एनीवे यू कैन लुक एट. सो माइनस 3 extreme in this side on the left side and plus 3 on the right side. So phi of 3 0.99 and phi of minus 3 0.000135. So its value will come 0.99. So in the tables, that's why you will find the tables have been generated from minus 3.5 to plus 3.5, because below minus 3.5 area is very, very small, and above plus 3.5 very, very small. Say suppose you in a certain problem, if you are solving probably, and after the conversion it is coming probability z greater than 4.5. So automatically you can choose it's 0. Similarly, z lies between minus z is less than minus 5.5, then area is 0. So no need to see the table. So having done this, so have you understood how to see the table values? Follow me? Or again, should I open the table and show you? Hello, we have
Yes, sir, got it.
got it ना. हाँ, थोड़ा बीच बीच में बोल दिया करो, ठीक है? नहीं होगा तो फिर से again I will explain. So as I was telling that if I have to get this, I need to solve this one. As I told you, in order to get the median, you have to solve this. X less than MD is equal to half. So one way is that you solve this integral, which is equal to half, and get the solution of this. So instead of that, since I need to calculate this probability, this one, okay, so I will convert into the standard normal. So in standard normal, I have converted x minus mu by sigma. MD is the point which represents the median. Okay, so that value we need to find out. So median minus mu divided by sigma, this equal to half. So this becomes z less than z1 is equal to half. So it is a reverse problem. Reverse problem is given the area, what is the corresponding point? Okay. So since we know the total area is 1, you are looking for a point below which area is half. So either you go back to the table and look for that also. In between, I'll take another example to show you. Instead of looking the points, the first row, first column and the first row, you look for the area inside the table where 0.5 value is coming, and you will find 0, 0. So intuitively also it is clear, because Z1 has to be 0, because below this area is half, above this area is half, 0 is the central value, which divides the distribution into 2 equal parts. So automatically Z1 becomes 0, means probability Z greater than z less than 0 is half. So z1 value is 0. So z1 is 0 means md minus mu by sigma, because this value we represented by z1. Okay, if you look at that here, this value we have represented by z1. So z1 value we have got, z1 is 0. So it becomes, when you simplify, it becomes mu. So instead of solving the integral, you can easily see that median is equal to now. So as we were talking the reverse problem, in most of the uh, uh, numerical problem, you need to find out uh, this type of probability, that find the value of b such that x greater than b is 0.25. Means you are looking for a point b beyond which area is 0.25. So how do we represent this in a graphical form? This is the normal standard, any normal distribution. You are looking for a point b beyond which area is 0.25. So what do? You convert this. So x minus 5 by 2, because here sigma is 2, mu is 5, and this point becomes b minus 5 by 2, 0.5. This becomes z, and this is a new point, b minus 5 by 2. So this I represented by z1. So ultimately, what did you do? You converted the original problem into the standard normal, where probability z greater than z1 is 0.25. Means if I want to plot this point on the x-axis, so z1 is here, okay, z1 is here, and what it says, you are looking for a point beyond which area is 0.25. So I have plotted in the black color. This area is 0.25. Tell me what is the point. So what is the point I have represented by z1? So since the table is not available in this form, tables are available in the cumulative form. So if this area 0.25, if this area is to be 0.25, then this complementary part, that 1 minus 0.25, which is 0.75, will be below this. So total area is 1. So instead of looking z1 beyond which area is 0.25, I will look for a point below which area is 0.75. Okay, so you go back to the table. Okay, go back to the table. Let me show you that you have to look for 0.75. So what you have to do? You have to look for a point, okay, below which area is 0.75. So we have to search in between side, not on the first row and first column. We have to look here. So looking here means 0.77 is there, 0.76, 0.735, 73, 74, 74, 74, 75. So nearest value is, because ultimately you are using the table. So 0.7517. Okay. So any one value you can use, because this will be also equal to 0.75 approximately. So suppose I have taken this value. So what is the point? Point is 0.68, means 0.7517 represents the area between minus infinity to z, and this z point is 0.68, means area below 0.68 is 0.75. So 0.75 we have got. So now so again, as you can see, this point we have got 0.68. So 0.68, Z1 becomes 0.68. So I put it here and solve for value of B. So B value is 6.36. So what it represents? X greater than 6.36 is 0.25. This B value is 6.36. Is it clear? So it is a reverse problem. My reverse problem is, instead of finding the area, you are finding the point. So another type of problem will be there, that you will be given the areas, means respective probabilities, and you need to estimate the parameters. Sometimes you need to estimate one parameter, sometimes you need to estimate two parameters, and two parameters means both mu and sigma square. So two parameters requires two equation, one parameter require one equation. Say for example, in this case, here you are given x less than 35 is 0.07, x greater than x less than 63 is 0.89. Okay, so these two statements are given, and using these two we have to find mu and sigma. Okay, mean and variance. So probabilities are given, we need to find the corresponding probability. So here again we have to the first equation, you take x less than 35 0.07, convert into the standard normal 35 minus mu by sigma 0.07. So z less than z1 is 0.07. Now where 0.07 means, you are looking for a point below which area will be 0.07. So certainly this point will fall on this side. So looking from the table, you are looking for a point below which area is 0.07. So again I will search the corresponding point under which the area is 0.07. So table value will give you minus 1.47. So Z1, which is 35 minus mu by sigma, is minus 1.47, 35 minus mu by sigma. Okay, so we have got one equation. Okay, now the second one is x less than 63. So again you convert this. So Z2, now you are looking for a point below which area is 0.89. So 89 is greater than 0.5. So area will, this point will fall on this side. So you look from the table, you will find the point Z2 below which area is 0.89. So corresponding to 0.89, the point will be 1.23. Means probability Z less than 1.23 is 0.89. So I have got another 1.23 equal to 63 minus mu by sigma. So we have got one equation, this one, another equation, this one, two unknowns, and after the solving these two equations, you will get mu equal to 50.24, sigma equal to 10.3. Okay. So in several numerical problems on the normal distribution, you need to find out the one parameter, sometime another parameter are given the probabilistic statement. Using that, we need to find. So you will solve some more problems in the assignment. Now, as I was telling you, that moment generating function. Okay, because normal distribution is another important property, that all odd order central moments are zero. Central moment means mu r is equal to expected value of x minus mu to the power r. So usually the higher order moments, if you need, it can be easily derived using the moment generating function. So here I will just give you the derivation of the moment generating function. So I have tried to explain each and every step. It is basically the solution of the integral. So we need to find the moment generating function of expected value of moment generating function, which is expected value of e to the power tx. So since we know the density function of the normal, so we write minus infinity to plus infinity e to the power tx and the density function of the normal fx dx. So we have to solve this integral. So solution of this integral, so what we do, we substitute x minus mu by sigma, we assume say z. So when you simplify, it becomes x equal to mu plus sigma z, dx will become sigma dz. And range will be when x tends to minus infinity, z will be minus infinity, x tends to plus infinity, z will tends to plus infinity. So the new integral will become minus infinity to plus infinity, e to the power t. Now x, we know mu plus sigma z, and 1 by sigma root 2 pi e to the power minus half z square, and dx is equal to sigma dz. So this is what the way we simplify. Sigma get cancelled. 1 by root 2 pi, the terms which are independent of z, we take it out. So e to the power mu t over root 2 pi, we have kept it outside, and then you have to simplify minus infinity to plus infinity e to the power t sigma z, and here is minus half z square. Okay, and dz is there, sigma got cancelled. So in order to simplify this, what we do, we will make a perfect square. So what we see, this is the next step, that you take minus half common. So z square minus 2t sigma z. So you have to make it in the form of perfect square, a minus b square. So as you can see, z is there, 2 is there. So t sigma is the second term. So what we do, we add t sigma square, t square sigma square, subtract minus t square sigma square in this bracket. Okay. So when you subtract, uh, uh, means if you adjust the term, e to the power t square sigma square will be out, and this term will become z square minus 2t sigma z plus t square sigma square. Okay. So one added, one subtracted. So if you simplify, then minus 1 will become plus, which has been taken out, and this which kept inside. So this becomes z minus t sigma whole square. Okay. And in the outside, e to the power mu t plus half sigma t square. So again, this integral you have to simplify. So z minus t sigma is u, dz will become du. Okay. So when you substitute uh, uh, this this one, z minus 2 t sigma by u, it becomes e to the power minus half u square d. And this is a standard integral, means its value is root 2 pi. Otherwise, what you can do, you can take 1 by root 2 pi inside, and integral of 1 by root 2 e to the power minus half z square dz is 1. So either you use that property, or you know this, the value of this integral is root 2 pi. So root 2 pi get cancelled. So ultimately, you have got the moment generating function of the normal distribution e to the power mu t plus half sigma square t square. And as I told you that for the standard distributions, we have to remember there is no other way. So uh, as you carry out number of problems or read repeatedly, these terms get remembered. So e to the power mu t plus half sigma square t square is the MGF of the normal distribution. So as I told you, the first moment you take the derivative. So I've tried to explain you. These are the simple derivations, and you will get mu. You get the second moment. Second moment is you take the derivative with respect to t, this twice, and put t equal to 0, because this formula we have given you. You will get mu square plus sigma square. Variance, you will get sigma square. As I told you, you can generate all the moments. So in general, all order, this is also one of the properties of the normal distribution, that all odd order central moments are 0. And so mu 2r plus 1 is 0, and mu 2r will be 1, 3, 5, 2r minus 1, sigma is by sigma 2r. So put the different values of r, you can get mu 4, mu 6, mu 8, and mu 1, mu 3, mu 5, all will be 0. So this is very important property. Then another important property is the additive property. What do you mean by additive property? Say, if you remember the geometric distribution and negative binary, what happens? Sum of the geometric means x1 plus x2, x3, as we have said, x1 plus x2 plus x3, xr. If each one are independent and follow the geometric distribution, their sum will follow the negative binary. Means you started with the geometric individual terms, but the sum, when you have taken and found the distribution, it becomes negative binary. Similarly, sum of the exponential follows the gamma distribution. But in normal distribution, it inherits the property that sum of the independent normal is still none. And we can show also using the moment generating function, that I gave you the formula also, that sum of the moment generating function of the sum of independent is the product of respective generating function. So there is a very important property that we call the additive property. Sometimes we call the reproductive property, that sum of the independent normal variate is a normal variate. So there are many problems which are framed, that one problem is, say you have a 3 pipes, and pipes have different diameters, okay, and they are connected. So this is one pipe, this is another pipe, and this represents the length, this is another represent the length of the second pipe, and third. So what will be the length of the combined pipe, which will be x1 plus x2 x3, and length follows the normal distribution, and we need to find out what is the probability that the total length will lie between certain interval. So such type of problems can be solved using the additive property of the normal distribution. So in the next class, I will discuss the additive property of the normal distribution. Two more things related to normal distribution. So I will stop here, and you just go through. If you have any, I will also work out some problems. So I will show you the problem sheet and solution. So is it fine? Hello. Okay.
Sir,
So I have another meeting, and so I'm leaving. If you have any doubts, etc., next class you can ask. Okay.
Okay, sir.
Okay. Thank you very much.